to hear a tone in your left ear. So whenever you hear the tone, you raise your finger like this and put it down as soon as the tone disappears. You'll have to raise your finger even for the faintest one. This is a 2 kHz tone. Right? Yeah, this is a 250 Hz tone. So 250 and 500, these are basically the low frequencies.
One more.
This is called brainstem evoked response audiometry or auditory brainstem response and all that. And this is basically, we give the stimulus through earphones and all that, or insert receivers, and we record the responses from the brainstem. And in case of adults, it's basically done to see whether is there any kind of retrocochlear pathology or something, means kind of tumor in the auditory pathway. So here it shows it's just fine, means nothing to worry about.
Those of us who are blessed with a normal hearing faculty often do not realize its importance in our lives. The ear is the first sense organ to develop in the human embryo. A baby is born with fully developed ears. Ears remain our most sensitive link to the world outside and beyond. Helen Keller, the educationist, who was deprived of the faculty of both sight and hearing, had said, "The problems of deafness are deeper and more complex than those of blindness, for it means the loss of the most vital stimulus, the sound of the voice that brings language, sets thoughts astir, and keeps us in the intellectual company of mankind." For a deaf child, learning is an unbelievable struggle. At the age of 2, a normal child, by listening to and imitating her elders, has acquired a vocabulary of almost 300 words. A deaf child of the same age and intelligence may have no vocabulary at all. Let us take a peek into the marvel of miniature engineering, the human ear.
Yeah, light is there.
What we commonly understand as the ear is little more than a flap of skin and cartilage, a mere appendage called the pinna. Other mammals have more impressive pinnae that perform the function of collecting and channelizing the sound. The pinna leads to the auditory canal, about 2.5 centimeters long. The auditory canal ends in the tympanic membrane or the eardrum.
The function of the external ear is to protect the sound against pressure and humidity changes, and also it acts as a resonator for the sound wave where for the frequencies where the acuity of the sound is maximum, like say from 3000 Hz to 5.5 kilohertz. It also consists of hairs which arrests the dust and engulfs the bacteria through the secretion of sebum, which we commonly say as ear wax.
Around 12 o'clock.
The eardrum of a healthy ear responds to an amazing range of intensities. The faintest audible sound is so weak that it makes the eardrum vibrate by 1/10 of a diameter of a hydrogen molecule. And the same eardrum can withstand sound 10 million times stronger. Beyond the tympanic membrane is the middle ear. Here one encounters the three smallest bones of the human body: the hammer, the anvil, and the stirrup. The three bones together are called ossicles. Nicknamed according to their shapes, the stirrup is the smallest of the three bones, being half the size of a grain of rice. The formal names of these three tiny bones are malleus, incus, and stapes. These three bones, working in tandem, amplify the feeble vibrations of the eardrum and pass on the disturbance to the inner ear. In the inner ear, the vibrations are picked up by nerve endings and sent to the brain.
The malleus is very firmly bound to the tympanic membrane, and the vibrations of tympanic membrane are transmitted to the malleus. With malleus is attached the long handle of the incus. The binding of the malleus with the tympanic membrane is such that for these three bones, which together forms a lever system, the fulcrum is just at the boundary of the binding of the tympanic membrane with the malleus, and the malleus and the incus functions as a single ossicular lever system. The entire lever with its fulcrum near the tympanic membrane is balanced by the smallest bone of the body, that is the stapes.
The three tiny bones are held in place by a set of muscles which also protect the ear from loud noises. Loud noise triggers two sets of muscles. One tightens the hammer, thus restricting its ability to vibrate. The other pulls the stirrup away from its link to the inner ear. The middle ear has another safety device, the eustachian tube.
This air comes through a tube we call eustachian tube. So, this tympanic membrane in place, they are not going this side or that side due to the air pressure in the middle ear and air pressure in the outer ear. That means 760 millimeter of mercury. This will be the equal on either side. As for example, I am just telling you, we are in air pressure, any flight, what had happened? When it goes up, suddenly we feel some pressure changes, hearing difficulty also. Due to what reasons? On outer side, air pressure is on that air pressure within the flight. But here, the air already we have swallowed or yawning, chewing, the air comes to this side. So, this air pressure is down air pressure, that means 760 millimeter of mercury, but here it is much less. That is why we feel some pressure changes.
The bone levers in the middle ear amplify the vibrations 2 or 3 times. But when the stirrup knocks at the oval window, the gateway to the inner ear, amplification of the order of 15 or 30 times can take place. This is possible by the difference in the areas of the eardrum and the oval window.
The area of the tympanic membrane is about 55 millimeters square, whereas the area of the round window is only about 3.2 millimeters square. We know pressure is equal to force per unit area. So, because of the difference in the area between the tympanic membrane and the oval window, the sound pressure at the level of the oval window is magnified by 17 times. So 17 times magnification of the sound wave due to the difference in the area multiplied by 1.3, which is magnification due to the ossicular lever system, the sound force is magnified by 22 times at the level of the oval window. Thus, middle ear transforms large amplitude, low force vibration into large force, low amplitude vibrations, and vice versa.
The inner ear is a coiled tube called the cochlea. It is filled with fluid.
A child in mother's womb at 4 months usually starts our inner ear develops. So during that period is we call it gestation period, 4 months period is very vital, as at that time inner ear is developing. So during that, if there is at that time some influenza fever, some viral fever, so or during that period patient has taken some drugs which is toxic to the ear, so that causes ultimately in future some congenital abnormality or so. So this 4 months of pregnancy period is very, very important. From the oval window up to this part is called inner ear. Inner ear consists of two parts. One is cochlea, one is vestibule. One gives us informations about our positions in relation to our environment, whether we are standing or sitting or we are jumping or we are in motions, whatever the things, this part giving us the information both static and dynamic. In respect of hearing, this gives us the hearing acuity of total sound of the whole environment. But we are mostly concerned with our communications, that means speech frequency, which are from 125 to 8000 decibel is ultimately the speech frequency is very important.
At the oval window, the vibrations encounter an abrupt change in the medium, from air to fluid. Thus, the need for this amplification of the sound. The unrolled cochlea reveals a flexible cochlear duct that separates the vestibular and tympanic canals. The canals are filled with a fluid called perilymph, and the ducts are filled with endolymph. One of the two walls forming the cochlear duct is the vibrating basilar membrane, whose most important function is to separate sounds according to their frequencies.
On the basilar membrane is situated the organ of Corti, which consists of two types of hair cells across the tunnel of Corti, or the two rods of Corti forms the tunnel of Corti. Inside the tunnel of Corti is present the fluid corticolymph, which is similar in composition to that of the perilymph, and inner to the inner rod is a single row of inner hair cell, and outer to the outer rods there is 3 to 4 layers of outer hair cells. There are about 3500 inner hair cells and there are about 20,000 outer hair cells.
The organ of Corti converts hydraulic pressure into electrical impulses. The tips of the thousands of hairs are in contact with the tectorial membrane. Shearing action between the membranes causes the hairs to bend, and their cells then generate electrochemical impulses for transmission by the auditory nerve to the brain.
The beauty of arrangement of the nature, that hair cells are so positioned from the basilar membrane and their hair projecting into the tectorial membrane, that there is such a huge potential difference which causes even very minuscule energy to be perceived and to be transmitted into the neuronal impulses.
This mechanism is one of the best protected parts of the body. It is encased in the cochlea, which, in turn, is deeply embedded in the temporal bone. From this well-guarded site, the organ of Corti relates to the brain the entire range of frequencies audible to us. The sound impulses, having entered through the oval window and set up hydraulic pressure waves in the cochlear fluid, finally get dissipated through the round window. The basilar membrane, besides reacting to airborne sounds, picks up vibrations in the skull. When we click our teeth, sound reaches the inner ear primarily by bone vibration.
This test, we call it tuning fork test. We put sound, ultimately this sound transmitted to the brain and hears. But this sound transmission, and when we put the sound here or back of the sound, there are also transmissions. But this transmission of sounds transmitted through bone, this is the bone, ultimately bone, and ultimately transmitted to this cochlea, through cochlea the nerves. So we can hear the sound from front by not touching there, also by putting sound here. But usually this sound is more magnified or amplified, so it amplified more usually in normal hearing. So this sound hears much higher than if we place this on that side, because this is directly transmitted through air. So 20 times, 17, 18 times transmission by leverage and other actions it has lost, so it is much less.
It is said that when Beethoven lost his hearing, he used to press one end of his conductor's baton to the piano and bite the other end with his teeth. The sound got transmitted directly to his inner ear. Mary Heiner, who had gone deaf at the age of 20, has written, "When your ears have been busy bringing to you the sounding world for almost 19 years, the abrupt absence of that part of consciousness is too astounding, too bewildering, too frightening to be summed up in one word: deaf. I had gone to sleep in a secure world full of sound, wonderful dancing sound. And I awakened in a silence as woolly and obliterating as deep snow in the country."
There are two types of hearing impairment. One impairment, we call it conductive deafness, and another is perceptive or sensory neural deafness. That means conductive means conduction system, any problem in terms of conduction system, and sensory neural means it is a nerve deafness. I have seen she had a discharging ear after a bathing also, and she feels too much of pain and recurrent bleeding was there. The reasons behind this tympanic membrane or from tympanic membrane and middle ear, she had some disease. We call it chronic suppurative otitis media, where there is an infection started through this tube and there is a collection of pus here, and that perforates the tympanic membrane. So this is the tympanic membrane which was perforated. Due to this perforation, she cannot hear properly. That is why she told in that way that my hearing was diminished. Nepal, in whom we examined, suddenly developed sudden vomiting, giddiness. That means affections either in vestibular system and also the cochlear system. In the vestibular systems, he developed giddy. That means and also vomiting. What had happened? The viral infection here and here. That is why this part middle ear is perfectly all right. So there is no conduction system loss, only nerve loss. So this nerve, the disease, that means the cell of this nerve, this cochlear cell nerve has destroyed by a viral disease. That is why his hearing was diminished, or there is a total loss of hearing. If it is higher than this, that means conduction loss. But when this sound is higher than this sound, that means either the person is normal or the nerve, because here also because these nerves are weak, so this is not transmitted properly, that is why it is diminished. So either normal or there is a nerve deafness.
Those of us blessed with normal hearing assault our ears mindlessly. Being constantly exposed to loud noises may cause permanent or partial deafness.
Second date, 1, 2, 3, 4.
Those who are born with hearing impairment have to cope with several problems besides the problem of communication.
3, 4, 1, 2, 3, 4.
For some reason, that is not entirely clear. A poor sense of balance and rhythm often accompanies deafness. Many deaf children find simple feats of coordination extremely difficult. Since the young dancers cannot hear either the recorded music or the voice of the caller, they must memorize the dance steps in proper order, relying on the faint vibrations they can feel and the low thumps they can hear to set the all-important measuring beat.
10, reverse. 1, 2, 3, 4, 5.
The complicated structure of the human ear can be traced down the evolutionary line to simple aquatic animals. Simple balance mechanisms are found in jellyfish, which signal the upturned fish to right itself. Balancing is a secondary function of the human ear too. Many aquatic creatures have a remarkable system called the lateral line that helps them to sense the faintest currents in the water around them. Amphibians have developed new large eardrums designed to hear sounds of the dry world. Birds have ears like ours, but their cochlea is shorter and almost straight. They can hear and respond to fluctuations in a song almost 10 times faster than humans. Insects, by far, have the most efficient hearing system. Having taken a different evolutionary line, they have dry ears. The insect's ear cavity is enclosed by the eardrum on one side and a counter tympanum or a release valve on the other. The auditory nerves are connected to the eardrum and pick up its vibrations directly. The human ear, in all its complications, can distinguish between 400,000 different sounds. Even after decades of study, the full capacity of the ear can only be guessed at. The human ear may be divided in 3 parts: the outer, middle and inner ear. The outer ear consists of the pinna, auditory canal and the extremely sensitive eardrum. The middle ear consists of a lever system consisting of the 3 tiniest bones of our body: malleus, incus, and stapes. The function of the middle ear is to amplify the sound. Stapes knocks at the oval window, gateway to the inner ear. The inner ear is the fluid-filled, coiled cochlea, where the mechanical pressure is converted into electrical signals. The electrical signals are picked up by the nerve endings and transported to the brain. Hearing impairment can be congenital or acquired. Usually, acquired hearing impairment is caused by the damage of the eardrum, and this can be cured. The human ear has evolved from the simple balance mechanisms of aquatic animals. Working together, the structures of outer, middle, and inner ear perform acts of amazing range and virtuosity.
Bye-bye.